Okay, this is part 2 of dividing polynomials. So here we're going to do a second division question. We're going to divide this polynomial by our binomial 2x plus 7. Now, something we didn't have to consider in the first example, because it was already set up, was arranging the polynomial in descending order of power. In order to do polynomial division properly, you need to have it in descending order. So what's that mean? Well, we need to have each term in the polynomial in descending power. So if this is our x cubed, or our third power term, the next term needs to be our second power, and then our power 1, or our degree 1, and then our constant term. And if it's not in that order when you try to do the polynomial division, it won't work out properly. So we do need to rewrite this. We need to rewrite this as negative 6x cubed minus 13x squared plus 38x plus 38. And the same applies for your divisor. 2x plus 7, it needs to be in descending order as well. Now that we're in descending order, we can set up a division statement. Or sorry, our division question. We're going to divide 2x plus 7 into negative 6x cubed minus 13x squared plus 38x plus 38. Since we're dividing a 2-term polynomial into a 4-term polynomial, we can't divide our single first term by a 2-term polynomial. So we have to skip that first spot and go right to the second spot. And now we're looking for what the quotient part would be if we were dividing negative 6x cubed minus 13x squared by 2x plus 7. And the key I said in the last video was that we're always trying to build to our first term. And the way we build to that first term is we look at the first term of our divisor and we say, what times 2x would give us negative 6x cubed? And the answer to that question is negative 3, because negative 3 times 2 is negative 6, x squared, because x squared times x is x cubed. So that's the first part of our division statement, or our quotient. And now if we multiply down, negative 3 times 2 is negative 6. X squared times x is x cubed. And we do the same for our second term. Negative 3 times 7 is negative 21. X squared times, well, there's no x here, so it's x squared again. And then we subtract. Negative 6x cubed subtract negative 6x cubed is 0. So we've eliminated that first term, which is the ideal. Negative 13x squared minus negative 21x is x squared is 8x squared. And we bring down our next term, plus 38x. And now the question is, if we're dividing 8x squared plus 38x by 2x plus 7, what times 2x would give us 8x squared? The answer is 4, because 4 times 2 is 8, x, because x times x is x squared. And now we multiply down. 4x times 2x is 8x squared. 4x times 28, or times 7 is 28x. And again, we subtract on the columns. Those two terms subtract to 0. 38 minus 28 is 10x. Last number to bring down, 38. So now we're trying to build to 10x. Something times 2x is 10x. The answer to that is 5. 5 times 2x is 10x. And 5 times 7 is 35. And if we subtract down the columns again, 10x minus 10x is 0. 38 minus 35 is 3. So we have a remainder of 3. And we have a quotient of negative 3x squared plus 4x plus 5. This polynomial did not divide evenly, so when we write our division statement, we're not actually writing a factored form because there will be a remainder. So we'll get to see what that looks like. So let's try writing our division statement. Divisor times quotient plus remainder. The divisor is 2x plus 7. The quotient is negative 3x squared plus 4x plus 5. And if it had divided evenly with no remainder, that would be our factored form. But since there was a remainder, plus 3, it's not factored form. And our dividend was negative 6x cubed minus 13x squared plus 38 x plus 38. So what we can see here is, again, if that was 0, that would mean that our divisor, 2x plus 7, is a factor of our original polynomial. But since it didn't divide evenly, it's not a factor. If you were to expand this out and collect like terms, you would end up with your dividend, showing that you would do your division statement or your division correctly. So if you ever need to check to see if you did your polynomial division correctly, write your division statement, expand it all out, and it should equal the original polynomial. Couple notes. If you notice how I've lined up my quotient, I lined it up directly over the divisor that's the same degree. So I don't write my x squared term above my x cubed term, I write it directly above my x squared term. Same with my x term, same with my constant term. And if you get used to lining it up like that, your polynomial division will end up going a lot smoother. Okay, so that's what to do if your polynomial is out of order. What happens if your polynomial is missing terms? By missing terms, I mean we have an x cubed term, but we don't have an x squared, we don't have an x, we just have a constant term. We're missing terms. In order to do division, when you're missing terms, you have to use something called a placeholder. Here's what a placeholder is. What terms are missing? The x squared term is missing, and the x term is missing. To hold place in that polynomial, the only thing we can insert is a bunch of zeros. So we can insert a 0x squared and a 0x. And that can take the place of those missing terms. It doesn't change the polynomial because it's just 0, but it does hold the place. So our polynomial rewritten for polynomial division would look like this. 8x cubed plus 0x squared plus 0x minus 7. And if you're missing the term, you have to insert a placeholder modeled just like this. 0 and whatever power you're missing. And then you'll be able to do the division properly. So let's try that division. We're going to divide 8x cubed minus 7 by 2x plus 3 by inserting placeholders. So 2x plus 3, and we're going to divide that into 8x cubed plus 0x squared plus 0x minus 7. We've got our placeholders inserted. So we're going to start here at 8x cubed. We can't divide two terms into one term, so we move immediately to our second term. And now we're looking to see what times 2x gives us 8x cubed. Well, 4 times 2 gives us 8, and x squared times x gives us x cubed. Notice the convenience of always lining it up. You always know what x power you need to multiply by that first term to get that term in the dividend. And 4x squared times 3 would give you 12x squared. And now we can subtract. Down the column, 0 minus 12 is minus 12x squared. Bring down a 0x. And now the question is, 2x times what gives us negative 12x squared? Well, the answer, of course, is an x because we're going to line it up over the x's. X times x is x squared. Something times 2 gives us 12, negative 12. And the answer to that is, well, negative 6. And I wrote a plus sign, so I need my whiteout. Negative 6x. Negative 6x times 2x is negative 12x squared. Negative 6 times 3 is negative 18x. And now we can subtract down the columns. Be careful when you're subtracting because double negatives turn into positives. So negative 12 subtract negative 12 would be negative 12 plus 12, which would be 0. And 0 subtract negative 18 would be positive 18x. Bring down minus 7, or negative 7. And we got one more. Something times 2x gives us 18x. The answer is 9. 9 times 2x gives you 18x. And 9 times 3 gives you 27. Subtract again. We end up with 0 in our x column. And negative 7 subtract 27 is negative 34. And that's our remainder. Okay, we could write a division statement here, but it didn't ask us to write a division statement, so we won't. and we have a completed polynomial division, and again we have a remainder. That was dividing using placeholders. We also did dividing by first rearranging the polynomial, and we did a much simpler example in the first video lesson. That's it for dividing polynomials. However, if you don't like polynomial long division, there is an alternative method called synthetic division, and the next two videos are going to show you how to use synthetic division. Synthetic division is not a mandatory process. However, learning synthetic division will add to your toolkit, and it will help you do your polynomial division potentially quicker and potentially more efficiently. It depends on whether or not you like the process. So my recommendation is, if this felt overwhelming, just the polynomial division, stop here and you can try some synthetic tomorrow in class. If you feel like you've got a good handle on polynomial division at this point, try taking a look at synthetic division. Okay? Thanks for watching, and I'll see you next time.